Okay, now let's look at this question. We have a blue light of this frequency. Bombards a metal of this. Okay, and we have a photoelectric effect. And here is the graph. Okay, on the graph, on the horizontal axis here, okay, we have the voltages. And this voltage is the stopping voltage. Okay, and vertically speaking, we have a current. Now, just let me basically briefly explaining what's stopping voltage. Okay, in Einstein's experiment, okay, he will have something like this. Okay, he will have a yep, okay, something like that. Okay, so here is a piece of metal, and we have collectors. Okay, then they are connected in uh, in a circuit. Okay. Now, if I have light shines on it, electron would escape in this way. Okay, escaping to the right, and hence, if electron moves in this way, so the current should go in the reverse direction. Okay, so the current of the induced current here should go to the left. Okay, but okay, what he did was, okay, he tried to put a voltage. Okay, he tried to apply a current and voltage in this direction. Okay, so it prevents. Okay, so this prevents the electron from moving to the other side. Okay, so by stopping voltage, what it means is the voltage that can be applied to this circuit in order to stop this electron from moving, from bombarding around. Okay, so yep, if you're confused about this, don't worry too much. Okay, just remember when you say the graph stopping voltage, when you see this kind of graph, okay, recognize this is a stopping voltage. Okay, now the stopping voltage tells you the maximum kinetic energy of the electron. Okay, it's the kinetic energy of the electron. Well, it tells us the kinetic energy of the electron because stopping voltage is a voltage and the kinetic energy of electron is in joules. It's measured in joules or electron volts. It should be a measurement of energy. Okay? Okay? But they are related. Okay? And now I'm going to tell you how they are related. Okay? Say if the stopping voltage is 2 volt, 2 volts, it means this means the maximum kinetic energy of each individual electron after escaping, okay, it should be 2 electron volts. Okay. So, yep, if you don't understand the theory or you have trouble understanding the theory, okay, I mean, okay, just recognize it. Okay, just recognize this thing, and 2 weeks later you may figure you may be able to figure it out. It takes time. This is a very hard concept, and it takes time for everyone to understand it. It just takes time. But in the meantime, remember this: stopping voltage tells us the kinetic energy of the electron after escaping. So if the stopping voltage is 2 volts, the maximum kinetic energy of the electron is 2 electron volts. Just remember this. They're related. Okay. Now, in this question, I'm asked to sketch the curve, the same curve, if the light is changed to a higher frequency, ultraviolet, which is a higher frequency than blue, with a lower intensity, okay, of light. Now, let me sketch the graph. Okay, so remember your equation. The maximum kinetic energy is the energy of the photon take away the work function, okay? And the work function is the same. Okay? The energy of the photon this time has been increased, so the kinetic energy has been increased. When the kinetic energy is increased, it means the stopping voltage is increased. Okay? But when we well, the magnitude of the stopping voltage is increased. Here is 0, so the stopping voltage should be, the magnitude of it should be higher. Okay? So this is 2, this is perhaps 3 or 4. Okay? Then it goes to rise up. Now, the other important thing is the lower intensity. Think about what we talked about before in this question. Current is the measurement of intensity. Okay? Now, lower intensity, okay, in a photoelectric effect means there are less number of photons. When we have less number of photons, it interacts with less number of electrons. Thus, less number of electrons is escaped. So the current should be lower. So you should have something like this. Yeah, because the current has to be lower due to the lower intensity. Yep. Okay. So this is how we sketch that graph. Now let's go on to the next question. Yeah, whatever question it is. Okay. Now in this question, I have a graph. Okay. Just remember. Yep, I have a graph. Now, okay, but in this time, the horizontal axis is frequency. Yeah, that's fine. However, the vertical axis is the stopping voltage. Okay. Now, just remember. Have a look at those kind of things. In the previous question, the vertical axis will be the maximum kinetic energy. Okay. However, in this case, the vertical axis is the stopping voltage. Okay. Now, when you say stopping voltage, don't be afraid. Okay. Stopping voltage is an indication of maximum kinetic energy. Okay. Yep. And it can be easily converted to maximum kinetic energy in electron volts. Okay. So what I'm going to do here is I'm going to cross this out. Okay. Then I write down maximum kinetic energy instead. Then the unit should change from volt to electron volts. That's it. And you do this type of question in exactly the same way as you do this type of question. Okay. Now let's say the question asks me to find the Planck's constant h. Now remember, the Planck constant is the gradient. Okay. H is the gradient this time. Okay. Because y equals mx plus c. Okay. Now we have kx equals to hf well, take away the work function. So I have work function here, threshold frequency here, threshold frequency at this point, and the gradient of this straight line is the work function. So what we do, Planck's constant, try to find the gradient, rise over run. So what you do is you just do your year 10 math thing. Okay, so yep, it rises 2 electron volts, okay, over a horizontal distance of 7 take away 3, okay, times 10 power 14 hertz, and put in your calculator. This should be fine. Done.